Hello and welcome to the second video in identifying the properties of 3D shapes. 3D, three-dimensional shapes. In the first video we looked at these shapes here. We looked at the cube, the cuboid, the triangle, the prism, the cone and the sphere. So today we are going to be looking at the 5 remaining most common 3D shapes, which I've got laid out here. Now, I should say at this point that you can download these worksheets for free on the TES website, the address of which I am giving in this video. I have also provided the same information on landscape view. So it's almost identical, it's just turned to landscape view. Now, the first shape we're going to look at is this shape here. And the number of vertices, does it have any corners? The normal word for a vertex? No, there are no vertices. What about the number of edges? Well, we've got one continuous edge here. So to fill in the first part of the worksheet, there wasn't even a single vertex, so it's a 0 or a 0. But the number of edges was 1. Now the number of faces, if you remember when we looked at the cone, which did have a vertex, just about there, we saw that it had 2 faces, this face here and this rounded face here, which is almost half a circle, and that will give you a clue towards naming the actual 3D shape. Well, number of faces, 1, 2. Now, where my worksheets differ from most worksheets is that I've got another column here where I think it's very useful to actually, at the same time, name the 2-dimensional faces that we can. Remember, 2D stands for 2-dimensionals when we're thinking of just length and width, just 2 dimensions, not a third one, which I gave the example of a swimming pool. You can swim a length and a width, so you've got your 2-dimensional flat shape. But if you dive down, then you've got a third dimension if you dive down through the water. So we had a circle. As far as naming the other face, we can't actually give this a name other than saying it's a rounded surface. If you were to unpeel an orange very carefully in one piece and you had cut it in half to start off with, I know that's very impractical, but if you had cut it in half and then you'd taken off the peel, this is what you would be left with. Now the name of this 3D shape, not exactly a half sphere, but what we call a hemisphere. I'll put a hyphen just there, and the spelling of sphere, quite tricky. Hemisphere. Now, let's look at our next shape. This will be a very familiar shape to anybody who has seen photographs of those amazing constructions in Egypt. So, let's have a look at the number of vertices first. Well, thinking about the number of corners, but strictly speaking, mathematically vertices, we've got a vertex at the top there, and we have 4 vertices at each corner here. So 1, 2, 3, 4, 5. The number of edges. Well, starting at the top, 1, 2, 3, 4. Turn it upside down. The next number to count is 5, 6, 7, 8. So we've got 8 edges. The number of faces. Normally faces are flat, but as we've seen in the hemisphere and in the last video of the sphere, not always flat, but mostly. 1, 2, 3, 4, 5. 5 faces. Now the names of these 2D faces, I feel it's useful to be considering the names of 2D shapes as well. Well, at the bottom here we have a rectangle. In this case it's a special sort of rectangle called a square. So you can either write down square or rectangle, but as we're a bit short of room, let's put square. And the familiar 2D faces which make up the remainder of the shape are triangles. Now, if you're trying to do this at the same time, you'll need to keep pausing the video if you're trying to write your answers ahead of me. So we've got triangles. And the name of this 3D shape is, you probably guessed that it's a pyramid, but it's a particular type of pyramid. It's called a square-based, because that's the base. The square-based pyramid. So let's write that down here in the answer box. Square-based pyramid. Many mathematical words are tricky to spell. Now the next shape does share some properties with the shape that we've just looked at. So, but some of the answers to these boxes will be different. The number of vertices. Well, if we put the shape like that, we can see we've got 1 at the top, and around these sides we've got, count that one already, 1, 2, 3, 4. So we write down 4 in this box just there. The number of edges. 1, 2, 3, 4, 5, 6. So we can see some differences between this shape and the shape above. The number of faces. 1, 2, 3, 4. And the names of these faces, or these two-dimensional faces, well, the base is a triangle, and in fact the sides are triangles too. So, different from the pyramids that you would find in Egypt, which are all square-based pyramids or rectangular-based pyramids, this is made up of triangles. And so this is called a triangular-based pyramid. Two more shapes to look at in this lesson. Now, most students or pupils in Key Stage 1, Key Stage 2 classes find this shape fairly easy to name. Spelling might be different though, but let's have a look at the number of vertices. Can you see a vertex on this? Can you see a corner? No, there is nothing which we could call a corner. So that's going to be a 0. What about the number of edges? And if you're filling in this at home, remember to pause the video so you can write what you think is the answer in first. The number of edges. Well, we've got 1, continuous edge and a second continuous edge. So let's put these two answers down together. There were no vertices, so that's a 0 or a 0, but there were two edges, one at each end. Now, the number of faces. Well, at this end, we've got one face, two faces. Do we have a third face? We do. We have this face, this continuous face going round. So, it's a total of 3 faces. If you think you know the name of this shape, you can always write it there. But let's do this little extra step first in naming the 2D faces, which I hope doesn't confuse. Well, what shapes have we got at each end? We have got circles. A circle. And what shape have we got running round here? Within some of the other round shapes, I've said it's very difficult to describe this other than a rounded surface. But this actually, if you were to look at the net of this shape, you would find there were 2 circles. And this shape, if we could unroll it, would roll out to become a rectangle. And it's curved round, so if you were to look up on the internet and the net of this shape, you would find that you would need 2 circles and a long rectangle to roll around and then join them up, and you would have made a cylinder. So I'm just going to stress that the words in this final column are the names of the 3D, 3-dimensional shapes, but the names here are 2-dimensional. The circle is 2-dimensional, the sphere is 3-dimensional. Squares and triangles and rectangles are 2 dimensions. They're just made up of 2 measurements. But pyramids and cylinders and spheres, cubes and cuboids from the first video are 3-dimensional words, made up of 3 dimensions. One more shape to look at in this video. That's this one over here. And the colours don't matter, it's just the way that the manufacturer has made them. But what I've got here are the photographs of these actual shapes when I made these worksheets. Now, this is a tricky shape, not only to count, but to name. Now, the number of vertices. Well, looking at the corners, I must stress the word corner is not a mathematical term. These are vertices. We have got 1, 2, 3, 4, 5, 6. And if you're worried about missing one out or counting one more than once, it's easily done. If you were to use a non-permanent marker and put 1, 2, 3, 4, 5, 6, that might be helpful. Turn it round. 7, 8, 9, 10, 11, 12. So there are 12 vertices on this shape. The number of edges can sometimes correspond with the number of vertices. So we'll see if it's true in this case. Well, in this case, it would be helpful to write on the shape, if you're allowed to, and then rub it out afterwards. The number of edges: 1, 2, 3, 4, 5, 6. And we'll double that because we've got the same shape at the other end. 6 and 6 make 12, so we had 6 there. 7, 8, 9, 10, 11, 12. That's where our 12 comes from. But we mustn't forget these edges too. And this is where writing on the edge would be helpful, so you don't miss one out or count it twice. How many did we have? We had 6 there, 6 there, 12, 13, 14, 15, 16, 17, 18. So we've got 18 edges. That's quite a lot, isn't it? more than the number of vertices. The number of faces, well, we can see easily at each end we've got 2 faces, and we've got 6 faces here. We've got 3 at the top, 1, 2, 3, 4, 5, 6 faces. Add those on and give us a total of 8. The names of these 2D faces, well, at each end we've got a special 2-dimensional shape called a hexagon. A hexagon is not a 3-dimensional word. It's the name we give to a 2-dimensional shape which has 6 edges, 6 angles, 6 edges. And this shape here is a rectangle because we've got 4 sides. Each side opposite is equal, and these sides are equal. If they happen to be the same length, it's a square. If they are different lengths, those 2 must always be the same length, then it's an oblong. And the general word for a square or an oblong is a rectangle. Now, what name do we give to this 3-dimensional shape? Well, thinking about the name of the 2-dimensional shapes at the end, we have the word hexagon, and that's going to describe the type of prism this is. A hexagonal prism. Hexagonal prism. So, that concludes our 2 videos on the properties of 3D shapes and identifying them and giving them their 3D names. Remember, the 3D names are prism, cylinder, pyramid, another pyramid, and a type of sphere called a hemisphere, because